Yes, sir.
We use the limit, and why I didn't go too much into limits because I had sent that video on limits. I really hope everyone had a chance to look at it. So the formula is for the derivative of x is the limit, and we read this as the limit as h approaches 0. It means that the value of h is getting smaller and smaller, coming closer and closer to 0, of f into x plus h minus f of x all over h. So presenters, just let me know if this is accurate.
Yes, sir.
So basically all we are doing, let's say we're given a function f of x. So f of x is equal to, let's do 2x squared. So this is what f of x is equal to, 2x squared. Basically, let me don't do this one yet. Let me do one without a square. So let f(x) be 3x minus 2. So this is what our function is equal to, and it can also be written just as y. So your function is basically, we can write this as y is equal to 3x minus 2. If we use it like that, then instead of writing the derivative of f of x, I'm just showing you the variation because I don't want, when you see something that is different. Yeah. So if you're given a function as y in this form, then you just write it as the derivative of y. We put a little stroke there. Or it can be represented as d dx. So these are some of the things that you are going to see. All of this is saying you are taking the derivative, right? So the basic understanding, what you have to do to find the derivative of a function, let me just go back to f of x. As you can see in this bracket right here, instead of putting x in the bracket, the function f of x, you have to put x plus h. So basically what you're doing, you're putting x plus h for x. That's basically what you're doing in this one here. So let's substitute and see what we'll get. The limit as h approaches 0 of f of x plus h. So our function is 3x minus 2. But instead of putting 3x minus 2, I'll start with 3. I'm not putting x in this function. I'm putting x plus h. So it will be 3x plus h minus 2. Just let me know if you understand this part here, please. Yeah, instead of just putting the function 3x minus 2, this is what the original function is. But as you can see up here, they don't want x, they want x plus h. So wherever I have x, 3x minus 2 as in the original function, where I have x, I just add in an h right next to x there. So that's basically all we're doing there. Are we clear with this? F of x now is the original function. F of x is the original function. What's f of x? What is that equal to?
3x minus 2, sir.
Very good. So that's all we do. We substitute 3x now minus 2. So once you understand this part here, the initial substitution is the most important thing. Once we understand this here, everything else now is just trying to simplify what we have. Right? Now, before I go further, I really want us to get a good grasp of this. So I'm going to, what's happening here? Let's say I had taken out this function completely. Good. Good. And I use another function. Good. Yeah. Let's say the function was, I don't know why this computer is freaking out. Yeah. What's happening? Just bear with me, teachers. Say the function was f of x is equal to 5x squared minus 2. If we had to find the derivative of this function, same principle applies. So you start with f of x plus h. So what I'll have here, it will be 5x squared, but we are not writing x squared. What should I write instead of putting back x squared? Someone help me.
Sir, 2x.
Are you sure? Remember, instead of writing x, look what this function is asking for. Look straight above. They don't want x alone. What do they want?
Sir, minus 2.
No, look right here, man. In the formula.
X plus h.
Very good. So instead of putting x squared, I can't do that here. I have to put, in the place of x, it will be x plus h. That's why I stopped that example to just go this over. That you must understand the first thing you're going to do is replace x with x plus h always. So instead of just writing 5x squared, I have to write 5x plus h
Square
squared. Excellent.
in brackets, yeah.
And then I can write my minus 2. Is that clear with everyone?
Yes, sir.
Yes, sir.
So what about if I had 2x here? If this was the original function, I'm just playing around with this because once we get this, we have the entire thing. This substitution is important. If the function was f of x is equal to 5x squared minus 2x, now we have this 2 here. What will I put next?
X plus h, sir.
X plus h.
Very good. Very good. So once you get this, you have it. So now I'm finished with the first part. My f plus h function. All I need to do now is the second part where I minus my original function, which is the f of x function. So in bracket, I minus this, I'm at this part now. So what will I write in brackets here now? What's my original function?
5x squared minus 2x.
Excellent. 5x squared minus 2x. Right? All over h. Good. So once you can do this substitution, you are good to go. Everything from here is just simplifying. But if you don't get the substitution right, then you're in trouble. Are we clear with this?
Yes, sir.
So once we do this substitution, now I'm going to work down this one. So just so that we can see what happens here. But the substitution is the most important thing. So this would work out to the limit as h approaches 0 of, now x plus h squared is a perfect square. Now, Yeah, it's a perfect square. And you should remember the perfect square rule through algebra. This will be equal to,
Sir,
when we
x
simplify
square,
this,
x square,
uh,
2,
go ahead,
2xh,
excellent,
and h square, plus h square.
very good, plus h squared. Now, these things help you to work faster when you can remember these things, right? So that's what this will work down to. Are we good to go? Yes, no?
Yes, sir.
Minus 2x minus 2h. You have to be careful with your sign. Remember, it's a minus 2 multiplying everything here. Is this clear?
Yeah, you Pelican. Yes, sir.
Yes, no?
Yes, sir.
Yes, sir.
Great. Now this minus again, by everything here, that will be minus 5x square, and minus by minus, you really have to be careful with your sign. That will be plus 2x, right? All over h. The next step is to continue limit as h approaches 0. Now 5 is multiplying everything. Let me try to fast track this. 5x squared plus 5 to 10 x h plus 5h squared, right? Minus 2x minus 2h. Basically, just what's there. Minus 5x squared plus 2x. Now, what we usually do here, we cancel out, right? So you see I have a minus 5x squared. So if I put them together, that will cancel out that. Just let me know if you understand what happened there.
Yes, sir.
Someone else? Yes, no?
Yes, sir.
Right? Because positive 5x, and when we group them, you'll have the minus 5x, so they'll cancel out. Is there anything else that you see will cancel out there?
Sir,
2x.
negative 2
Very
x
good.
and
This
positive
2x
2x.
there, great. So this helps you to fast track the process. So what we'll end up with here, so we have 10x plus 5h squared minus 2h. Limit as h approaches 0. We have a 10xh here. We left with a 5h squared and a minus 2h. All over h. Now, the next step is actually factorization. That's what we do before we apply the limit. So if we factor out, what's common in the numerator? Let me hear you.
H, sir.
H.
H, great. H is common in every term, right? So if we take out H, we'll have 10x plus 5h minus 2. Is that correct?
Yes, sir.
Sir, why did we put that 5? Oh, now I realize. The square.
So we're good there?
Yes, sir.
Yes, sir.
All right. So now because it's a product, I can cancel out this h with this h. Now this is a big problem that we have, right? So let me show you why. This is the same as h over h times 10. All of this here, I really don't want to write out, over 1. So that's why the h and the h can cancel out, right? That is why algebra is a prerequisite for calculus. If you're weak in algebra, then we'll have some trouble. So I'm saying if you know you have some problem with science and those things, just go the extra mile to sharpen up. This calculus isn't so difficult if you have the algebra at your hand. So when we cancel out here, we are left with the limit as h approaches 0 of 10x plus 5h minus 2. At this point, we can't simplify further, so what we do, we apply the limit. Applying the limit simply says that we substitute 0 wherever we have h. So we'll have 10x plus 5 into 0 minus 2. So our final answer will be 10x minus 2. So that's the derivative of the function with force principle. So f, and our answer is not f of x, but it's the derivative. So I put that prime, the derivative of f of x. F of x was it 5x squared minus 2x?
Yes, sir.
Yes, sir.
Right? Great. So any questions pertaining to this?